When drawing a card from a standard deck, what is the probability you draw a red card or a 9? So we actually have a couple of different ways we could do this one now, even using the union rule. I could figure out n of e. Well, let me define what e and f are. I'm going to define e as the first event here and f as the second event, so that the probability of e union f, I'm talking about the probability of drawing a red card or a 9, so that is the probability of their union. This is going to be the probability of the first plus the probability of the second minus the probability of their intersection. Well, the probability of drawing a red card is 1/2. Now, it actually is less than helpful to write it as 1/2 in its fully reduced form. Instead, I would like everything, since I'm going to be adding and subtracting fractions, it's much easier to keep these all over 52. So instead of writing that down as 1/2, I'm actually going to do everything over 52. So the number of red cards, well, there's 26 out of 52 that are red cards. The number of 9s, well, there's 4 out of 52, and the number of red 9s, there's 1 out of the 52. You can see, I think maybe, hopefully it should be clear why this works. We're still doing 26 plus 4 minus 1, which is, what, 29 out of 52? This would be the exact same as if I was figuring out the n of, well, not quite the exact same, but very, very similar. If I was doing n of e union f equals n of e plus n of f minus n of e intersect f. Only these ones wouldn't be fractions. This would just be 26. This would be 4 because there's 4 9s, and there's 1 red 9. Oh, there's not one red 9. There's 2 red 9s. I made a mistake there. Let me fix that. There's 2 red 9s, which means that would end up being 28 out of 52. And I could reduce that, but yeah, it's going to bug me if I don't reduce it. 4 is a factor. We get 7 out of 13. All right, so here we would do the same thing. There's 2 red 9s, so I'll change that to a 2. You can see 26 plus 4 is 30, minus 2 is that same 28 we got up above. So n of e union f is 28. The probability of e union f is 28 out of 52. You can see it's pretty much an identical process. The reason we would we need the flexibility to go either way with this is because sometimes we're not able to deal with the number of outcomes of a probability. Sometimes all we can know is what is the probability. The number of outcomes of an event. Sometimes all we can know is the probability of that event. We can't know the number of outcomes. It might not even make sense to have a sample space. So that's where the union rule of probability comes in.